Okay, good evening students. Students, last class we studied about that is microprocessor and microcontroller semiconductor. This class we are discussing about that is different types of special diodes and IC integrated circuits IC that is using for inverting and non-inverting. These are this class we study. These are the very basic electron device. Okay, so we will go for the subjects one by one. Okay, first of all, what do you mean by electron device, where it is used, what are the applications you will discuss over here. That is an electronic device or component for controlling flow of electrical currents from purpose of information processing and system control. That is transistor and diodes. Okay, so electronic components you are studying for a lot of electronics components, for example a transistor, diode, resistor, capacitor, inductor. These are all the electronic components, electronic device. Based on that, how you are using, how they are controlling the current, how they are flowing for current and voltage. Okay, these are studying about this class. And one more beauty is different type of special diodes. This class beauty. Okay. Next, electron devices are usually small and can be grouped together into package called integrated circuits. Okay. Electronics have various branches including digital, that is, see, there is a digital electronics, analog electronics, that is above this topic is electronics. You can add the each and every, there is a different types of branches included. First of all, digital electronics. In this digital electronics you are studying for on off. Digital, that is the AND gate, OR gate, NOT gate. This is digital and using for combination circuits and sequential circuits. You are using for multiplexer, demultiplexer, encoder, decoder, comparator, then sequential circuit, synchronous counter, shift register. These are the synchronous circuits. These come for the digital electronics. Second, analog electronics. Okay, so using for the sine waveform, that is the amplifier, different types of amplifier, single tune, double tuned amplifier. Then using for the positive feedback, negative feedback amplifiers. Okay, accelerators. Okay, that's our studying about the analog circuits. Clipper, clamper, these are analog circuits. Next, microelectronics. Okay, that is using for the very large scale nanotechnology. It's a very large scale. Okay, using for the PMOS, NMOS base, you are using for this microelectronics. Then nanoelectronics, you are using the 10 to the power of 9 nanoelectronics, nanoatoms. Okay, nanoscience you are using for how you are using the electronic device, using for mobiles, different type of nanotechnologies in mobiles. Okay, then optoelectronics. In this optoelectronics you are using for optical, laser, lead, LED. Okay, laser light using components to transmit. Nowadays using for the communication, optical communications, using fiber cable you are using. Okay, fiber link you are transfer. These are studied about the optical electronics. Okay, this is optoelectronics. Next, integrated circuits. Integrated circuits you are using for the IC. Integrated circuit using for IC 741, starting from IC 741, IC 7412. It's in this way you can go for n number of IC, inverting, non-inverting, voltage follower, summer circuit, adder, and one more beauty circuits, that is a instrumentation amplifier. Okay, cascade amplifier. These are studying about the integrated circuits. And semiconductor device, you know, semiconductor device is pnjunction diode. Okay, then rectifier using p-type, n-type semiconductor material, PNP, NPN transistor, JFET, MOSFET. These are all the semiconductor device. Okay, so these are the important in electronic device. You are studying for the biomedical engineer, so you can know what are the different type of, because this everything is using in your lab or in your using for in your career. Okay, for example, if you are doing for laser, it will come for the optoelectronics, how to doing operation using laser. And for using for special type of, that is electronics, it will come for digital electronics, using for digitals, using for the ECG, EEG. It's for digital and analog electronics, different CRO, those things. Okay, pulse generator is come for the digital electronics. So different components based on these different type of devices, branches. Okay, so we go for proceed. Next slide. Okay, then integrated circuits. Okay, that is a IC. In integrated circuit or monolithic integrated circuit, also referred as IC or chip or microchip, is a set of electronic circuits. One of a flat piece, this is chip. Semiconductor material, that is normally silicon. The integration of large number of tiny MOS transistors, okay, metal oxide semiconductor transistors is a small chip results circuits that are order a magnitude smaller, that is faster and less expensive than those constructed discrete electronics components. That is a discrete and analog and discrete component. Discrete is come for the square pulse. It's called for discrete. Okay. Then IC are now used for virtually all electronic equipments. That is a revolutions in the world of electronics. Now we know that is a digital world. Okay, digital is electronics improvement. You can everyone have the mobile phone. Everyone using for the 4G, 5G. These are the digital advanced technology revolutions of the mobile versions. Okay. Then computers, mobile phones and other digital home applications are now inextricable parts of structure of modern societies. Okay, so nowadays you know there's a touch screens using for all those things. Automobile industries are boom and IT industry. Okay, so by small size can be for low cost. That is a made possible by small size and low cost of IC. So you can using size also small, at the same time using for the low cost. But if you go for an iPhone, it will come for a minimum 40,000. Okay, it's a cost high. So you want to integrate low that size and low cost, but high efficiency and high throughput. Okay, it's a beauty. Next you go for the what are the IC classifications. See, there is a 4 type of classifications. First one for small scale integrations IC, second medium scale integrations, third large scale integrations, fourth one very large scale. Okay, so small scale is that's up to 100 transistors minimum count. Medium scale 100 to 1000 transistors. Okay, so thousands and say above transistor, that's a large scale. Okay, transistor, and you are using for that large scale integrations. Very large scale, will I say more than 1 lakh transistors, the MOSFET, NMOS, PMOS you are using. These are all the large scale integrations. This is coming for how many IC you are using, how many IC package this coming for here. These are 4 type of classifications. Clear student? This is IC integrated circuit developments, small, medium, large, very large. Is a n number of components in the integrated circuit implemented stage by stage. Okay, so now you are studying for the very small scale integrations. There is a inverting, non-inverting. These are the small scale integrations. In this small scale integrations, inverting, non-inverting is a very important basic. That's a study for this class. And voltage follow here, instrumentation amplifier, integrator, differentiator. These are the small scale integrated circuit using for IC operation amplifier IC741. Clear? Op-amp operation amplifier. That particular IC is IC741. Clear? Next, that is a inverting amplifier. Okay, that is using for AV. That is where feedback is inverting. That is you give for the positive pulse, and this one it will come for the output. It will totally invert. Positive will come for the negative. Negative will come for the positive. That is a feedback. C. That is a voltage gain minus RF divided by RF. C. This is a feedback resistors. Say input resistor we giving for input voltage. That is inverting. Minus terminal and positive terminal. This IC is IC741. V out. So voltage gain, AV means gain, A for gain, V for voltage. Voltage gain is minus RF divided by II. That is a input resistance value divided by output resistance. Students, if you are studying for the inverting, you are discussing about the 4 parameter. That is voltage gain, current gain, resistance, input resistance and output resistance. These 4 parameters are important for inverting, because gain is important. Output divided by input is a general. In this output divided by input, you are using for the voltage. Okay, so voltage gain, output voltage divided by input voltage. Okay, so here how you are connecting for the feedback resistor. That is RF feedback resistor divided by input resistors. That is a inverting amplifier voltage gain. Okay, so why you are using for inverting means you want to convert voltage. Okay, this is a positive to negative or analog to digital conversions. This they are using for ladder circuit, 2 ladder, and this is using for the inverter. This is using inverters you are using for that. Okay, different type of application dependent. Okay, and gets large gets basics inverting. Okay, then non-inverting amplifiers. So this one for you are using for the non-inverting. You can give for positive side input. So what are the feedback you are giving for the input, you get for the output. It's a non-inverting amplifier. Okay, these are very basic in IC integrated circuits. Remaining things, if you go for the purely integrations, you go for inverting, non-inverting, then you come for oscillator, Colville oscillators. These are the RC phase shift oscillator. These are go for inverse area. Okay, so we want to in basic electronic device, you must know inverting amplifier, non-inverting amplifier, what is integrated circuits, what are the classifications. This is 4 type of classification. This knowledge is enough for even your basic electronic device. Okay, then you go for next special types. That's a special type of diodes, because its diodes are playing very vital role in electronic device. That's why we are reading for PN junction diode. Then PN junction diode, based on that you study last class rectifier. That's a half wave rectifier, full wave rectifier, and bridge rectifier. In PN junctions you have one more application also, PN junctions, that is a clipper and a clamper. That's also applications in electronic device. Okay, so this class we are discussing, it is a special type of diodes. First one for tunnel diode, photodiode, vector diode, and Schottky barrier diode, light emitting diode, silicon controlled rectifiers diodes. These are using for the SCR. Okay, otherwise called for SCRs. This is a special type of diodes. Okay, so in your electronic device you must understand, and biomedical engineers you must know different type of special diode. Why you are studying this one for? This is using for the photo. That's a photo energy to convert electrodes. Using for this one, you can be taking scan type. That time using for this one. Then light emitting diode. Okay, that's it. Using this type of will come for the lasers. Light emitting different type of. Okay, that you study. Okay, so students you can discuss one by one. Okay, first that is a tunnel diode. Okay, that's a tunnel diode, also known as a Esaki diode. Is a type of semiconductor diode that has effectively negative resistance due to quantum mechanical effect called tunneling. Tunneling diodes have heavily doped PN junctions, that is about 10 nanometer wide, that is anode and the cathode. This is a tunnel diode. Okay, so with this tunnel diode you can forwarding tunnel, that is a negative resistance. First of all, resistance means it will creating for the break, or it will create resistance for the voltage or current, it will following through the equipment. Okay, that is a symbol. See, that is a normal diode symbol. There's one bend is there. Okay, that's a very important. Okay, it's a Viva questions or basic your electronics, your biomedical engineers, you know basic electronic means that's a diode symbol and anode. This is a tunnel diode. Different type of diode symbol you must know. Okay, then only your basic knowledge awareness. Okay, that's a tunnel diode. Okay, so next you going for the constructions and operations. That's a tunnel effect. How this operating tunnel diode? See students, this is two layers in split up in here. That is a N type and P type, and give here that is a EC conduction band and EB valence band. What you are doing here, that is a N type. N type is N number of electrons is there. That electrons passes through here. That is electron passes through tunnel. That is a tunnel. This tunnel is the C. That is a EC valence band and the conduction bands. And the energy in valence band and the conduction bands through the time double, through the tunneling effort. That time in N type electrons convert to P type holes. That is electron pass through the tunnel, so holes. Okay, that is come for the tunneling effect. Another one same he said, there is a barrier. In this barrier, this is like a barrier. In this barrier, what is doing? This break-in, that is free through electrons in the get for electrons come from the electrons. N type electrons convert for P type holes actually. So electrons and holes now combine together. Then what will happen? The barrier will be reduced. So crossing here, so automatically the barrier will reduce. Finally the barrier disappear. Now this voltage or current flow is continuing. This is called for the tunneling effect. Okay, this is a tunnel. This tunnel will be broken, overcome. Okay, that's a tunnel effect, tunnel diode. Now VI characteristics. Okay, so PN junction materials, how these VI characteristics of tunnel diode. See, there is a reverse bias. This is a voltage bias. Volts in the x direction, y direction for the current in 1 milliamps. See, if you giving for this one, so this is go for the increase voltage and current are increasing. Then it will go for a particular point. There is a peak point. Then it will come back down. Then it will come for a particular point. Then it go for remaining again. So this increasing current called as a tunneling current. After the peak point, this is a peak point. After the peak back, it will come for the down. Down will come for the negative resistance. Then it will go for, that is a conventional diode current. After it will go for retribling. So this point called as a valid point. This valid point is a 1 second it will increase. Okay, So there is input voltage, there is a input peak voltage, this come for the valley voltage. Okay, probably 1 or 2 voltage, probably 1 to 2. It's a valley voltage of PN junction, that is a tunnel diode. This is important. VI characteristic means voltage and current characteristics, that is a function is VI characteristics. Clear? That is come for the one type of shape. Okay, it's a beauty of tunnel diode. Next, what are the applications, sir? You are studying tunnel diode. What is the purpose? Why you are studying this topic? Okay, tunnel diode, students, a lot of application is there in your biomedical. You are using for tunnel diode is very important. First point, tunnel diode can be used as a switch. It's important. On-off switch you are using for different type of biomedical equipment. The MOSFET switch, there's a tunnel diode also you can using for switch. It's a very low phase and low cost. That is important. You are using for this tunnel diode. Next, amplifier and accelerators. No, it's a Colpil oscillator, RC phase shift oscillators. They are using for a stable, monostable. Okay, these are for using accelerator. So using your electronic components are using for accelerator. Okay, that is also amplifier accelerators you are using for tunnel diode to produce that. Okay. Next, it shows a fast response. It used as a high frequency component because fast response. So in your high frequency component, there is a gigahertz, megahertz starting from kilohertz, megahertz and gigahertz. Okay, this is the range flowing in your. It is using for the tunnel diode high frequencies. Okay. Third point, tunnel diode acts as a logic memory storage device. Okay, it's an acting for the storage because it negative resistance store the can using for the storage device memory. The last but not least, they are used for oscillator circuits and FM receiver. Since it's a low current device, it is not used more. Okay, so it's a FM receiver you can use. This is a frequency modulation because you can segregate high frequency, low frequency, that is carrier frequency and message frequency. Easily you can segregate and store it. That is a using for FM receivers. Okay, using low current device. Okay, these are the application for tunnel diode. Okay, students, then go for next slide. Next, there is a varactor diode. Okay, what is meant by varactor diode? Where is that is a varactor diode? See the symbol. See, there is one triangle above you put for two parallel line. This is a varactor variable. There is a normal diode. You can put this one. Okay, this is anode and cathode. We can put one triangle diode. If for that you can put two parallel symbols. Okay, see. A varactor diode, also known as the names varicap diode, varactor diode, tuning diode. Okay, these are the different type name: varicap diode, varactor diode, and tuning diode. Why you are using tuning means, see here, this you put one arrow mark. This arrow mark is a tuning. Okay, now see the functions. PN junction diode, which act as a variable capacitor under varying reverse bias voltage across the terminal. There is a reverse bias voltage across the terminal. That is PN junction diode. So this is the symbol. Next, come for the construction. See, there is you are using normal PN junction diode. Only here you see a difference. Okay, this is a P type, N type made for silicon and galvanic arsenic GaAs metal. This in this metal is a new configurations. This you can connect it for one small yellow line. There is a gold plate to wire connected this. Okay, there is a ceramic tube. In the ceramic tube mounted. Okay, there is a anode and a cathode. Here anode, here cathode, here A and K, anode and cathode. In between P and semiconductor, P and metals, you can connect this type of metal. This is a construction. This is called for one varactor diode. This is a variable. Okay. Now is how it's working. See, that is in this depletion work. See, this is a P N junctions. That is a positive hole charge carrier. Here it will come for negative charge carrier. This is a depletion layer. Okay, there is a dielectric medium. So it's a junction capacitance. In this depletion layer, it is for the junction capacitance. What is the purpose? What is the function of capacitance? Capacitance is charging and discharging. It will charge 2 seconds. It will discharge 1 second. Okay, same function doing here. That is a variable. This is a junction capacitance. This is there. Okay, this is the normal PN junction, P type and N type material. Then newly added materials here. That is come for the your dielectric medium or depletion layer. When your depletion layer act as a dielectric medium, okay, it will hold in between P and N type. Clear? Then this come for the reverse bias voltage is a VI characteristics, capacitance and reverse bias. Then it will come for like this one. Okay, voltage 2, it's a current. Okay. Then applications of varactor diode. Okay. So automatic frequency controller is a varactor diode applications. Next, ultra high frequency televisions. Okay, ultra high. That is, you know, the TV is the UHF and VHF. Ultra high frequency, very ultra high frequency. Okay, this has come for the spectrum. Okay, you are in old days you are using for the picture tube. See, this cathode tube. Okay, vacuum tube using. That time using for this frequency transistors. Nowadays, everyone using for LED, LCD, and you are using for individual tower, not using for the Yagoda antenna, the central transmission channel radio stations, TV stations. Okay. Then high frequency radios. High frequency radio means, see, if you are using for FM, that will come for the low frequency, that is 90 Hz to 105 Hz. For example, 98.1 FM, 99.4 FM, that is 98.4 frequencies. The high frequency means 1800 to 1200. Okay, it's a high frequencies. Next, frequency multipliers. First of all, what will be multiplier? Many frequency multiply and get for the one frequency. For example, you could take for 4 type of frequency: F1, F2, F3, F4. So for 400, 600, 800, 1000. It's a 4 type of frequency multiplex and then transmitter. Is a frequency multiplier. Then band pass filter using for this Walter diode. Band pass filters, that is a filters. Filter means you can cut for unwanted signal and electric signal you want to remove. Thus 3 type of filter is there. That is a active filter, passive filter. After that it will come for the low pass, high pass, band pass and band reject filters. Here you are using for the band pass filter, particular band pass that in the particular component. That is a band pass filter using for the Walter diode. Then last but not least, the last one is a harmonic generators. Harmonic means it will come for the H1, H2. It's a varying the parameter starting from 1 voltage, 2 voltage, 3 voltage. What is the output? It's a harmonic generator using for Walter diode. Okay, these are the application you are using for Walter diode. Okay, students. Then we go for the next special diode. Okay, next special diode is a Schottky diode. Okay, a Schottky diode is a device which comes under the type of metal. It is a semiconductor junctions diode. It's a metal semiconductor junction. In before that you are using for the P junction. PN junction means P semiconductor, N semiconductor, PN junction. Here Schottky is a metal semiconductor using for the metal type of this one. Okay. Then here this is a symbol, anode and cathode. In this symbol you can see that is zigzag lines, just like a small Z in this zigzag, anode and cathode. Okay. Barrier diode and low voltage diodes are the other names for Schottky diode. When compared to a PN junction diode, okay, power drop is lower in Schottky diode. Okay, how it will come for the sun? That is a power drop is lower Schottky diode, power drop low power diode, that is using for the PN. Okay, when compared to positive, it's a PN junction diode. Okay. Next, how it come for the name Schottky? That is a scientist named Walter.H.Schottky first discovered Schottky diode. So he is find out Schottky this type of diode is putting for the end anode and cathode. When adding for this metal type, it will come for the Schottky diode. He put same scientist name, okay, Schottky. Okay. Go for next slide. See, that is the operation of Schottky. What is he using? How it come for it? See, it is a normal PN junction diode. In this PN junction diode, he made from the metal. That is indicating for the metal. That is electric current flowing. These are depletion layers. Okay. See here, there is come for light arrow is the free electrons. That is free. It will come for negative ions. Okay. This ion symbol is negative ions. That is a hash color oval. It will come for free holes. Is a positive ions. So you are giving for P type negative and N type positive. So opposite polarity you are giving. That time what will happen? In your free electron come for negative ion content and positive content for the positive ion. Okay. So based on this metal flow is happening, so it will flowing for the current. Okay. So automatically it will change its charge barrier depletion regions. It will come for here. This way it will be increasing. Okay. This is the construction operations of your Schottky diode. Okay. Then VI characteristics, how it is performing for input and output characteristics. In your PN Schottky diode, in your forward directions, automatically it will come for the just like in your PN junction diode. That is, it will come for it is decreasing. It will that's a linearly increasing. current and voltage increasing, same way it will linearly increasing, that is a forward characteristics. This forward characteristics as a normal as in PN junction diode, but reverse characteristics up to some voltage and time will go for ideal, that means it will go for maintain or 1 or 2 voltage, then it will come for reverse characteristics, there is decrease. Then how it will go for increasing this voltage, then negative resistance, reverse bias, then how it will increase in, that is a reason. See, in this you are using for free electron, it will come for negative ions, and free holes it will come for positive ions. So it will give, you are giving for the voltage continuously in some point, that's a particular point, it will fully in this metal fully it will come for positive ions and negative ions. So what will happen finally, it will come for positive and negative ions, it will current flow will happen positive and negative ions. So automatically in your circuit close, in your direction, current flow directions are going. So that's a, after that sometimes putting the holding probably 5 voltage or 7 voltage depending upon the metal, then it will come for the continuing, that is a reverse characteristics. Clear? It's a, this find out by Schottky scientist, that's like put the name Schottky, that is a Schottky Diode barrier diode. Okay. Next, in this, based on the Schottky, what are the applications? It's important because in your device you are studying electronic device, how we are using, what is concept and symbol, and what are the applications. Next, such as Schottky diodes are used in electronic industry for many applications in diode rectifier because in properties. First, they are used for voltage clamping application to prevent transistor saturations. That are clamping. Okay, clamping means you want to cut or you want to clamp, transfer fully forward direction or reverse direction. That time we are using for clamping to prevent transistor saturations. Okay, the transistor you should, there are 3 type of, the first one for cutoff region, saturation region, then it is using for increasing. Okay, that is a log regions. Okay, so it is acting for the saturation region. Then it is used for Schottky TTL digital device as the device required for fast switching tri-state logics. Okay, TT tri-state logic device, it's a TTL using for digital device is a Schottky is very important. Okay, use that. Then as the performance of digital computers is determined by switching speed of the diodes, so you want to act as a switch and very speed to using this one. Okay, then final last but not least, that the Schottky diode is an important component for digital computers. So in your digital computers, it's a digital pulse and all pulse you are using for digital computer, Schottky diode is very important. Okay. Then light emitting diode. Okay, LED. This is a lot of applications. This LED, because you are putting one charge. I will know this is a charging. Okay, you putting for you can switch on any if you putting for LED, for example mobile phone charging, that's a light indication. Then laptop, okay, that time you switch on that will light glowing. Then monitor, CPU, computers, these are the light glowing. Your keyboard on and your monitor on, there's a light glowing. What is that? That is a LED, light emitting diode. If you switch on means that automatically flow the current, so it will flow the current, automatically it will glow. That is a LED. It's a very most applications. If it all electronics device, it must have LED. So you are a biomedical students, you must know, study about the LED, light emitting diode, because each and every equipment you are using for scan, CT scan, ultrasound scan, so and so, blah blah, that is using for that is steganography and X-ray and using for n number of medical device. Okay, using scanning purpose and eye sensors, eye device, then pulsing rating you are using for EMF, pulse transistors, then ECG, EEG you are using for equipment, and you using for the frequency wave analyzer, network analyzers you are using. Okay, n number of different equipments, electronics is there. All these things have the LED. That purpose is in this component you have the current, power, voltage is there. Power means V into I, voltage into current, voltage into current is a power, watts. Okay, if your current flow is there, I, it's a voltage is there, V. Okay, if your current or voltage is flowing in the particular component means automatically it will glow. If you charging means that it will be red indications. After fully charged it will come for green indication. That's also one type of threshold level values. Okay, So this in day-to-day life is a very important on diode applications, LED, light emitting. And one famous one, that is you are using for the TV. It's a light emitting diode. You are so the HD print, so quality. It's a LED. So n number of LED connected. You can create for the board. Just a slide board model. Before that, before coming for the LED, you are using for the picture tube. Okay, that's a vacuum tube, CRT. Okay, cathode ray tube, CRT, cathode ray tube. That's called for the picture tube. Okay, so come for this big size. Nowadays, it come for the just like put the slide. Okay, so you can put in the wall or you put in place in the some other. This is a LED. And one more thing is also is that it's a LCD. So you are biomedical students, you must know the difference. LED means light emitting diode. It's a light emitting. Another one for LCD, that is a liquid crystal display. Okay, in between the crystal display is that passing through the voltage, it will glow. Okay, so first that is a LED. It's a very important. You must know. Everyone must know this one. LED. Nowadays, lot of applications you are using. Okay. So first, the diodes converts the electrical energy into light energy. First produced started in 1968. It undergoes electrolysis process in which holes and electrons are recombined to produce energy into the into form of light in forward bias conditions. So it will current flow coming means that time it will glowing. Okay, very simple. See, there's a symbol. See, that is you putting for anode and cathode, and diode you putting two arrow mark. See, otherwise you putting for one diode and put the round and put the arrow mark. This is anode and cathode. It's a conventional current to flow. This direction is a forward direction. So the reverse direction is acting as a normal PN junction diode. But in the forward direction it will come for acting as a LED. Okay, light emitting diode. Okay, this is a symbol. It's a very important LED. Okay, symbol. Then LCD, that is a Silicon Controlled Rectifier, that is a SCR. Okay, this is also one type of special diode, Silicon Controlled Rectifier. It consists of three terminal device. There are anode, cathode and the gate. Okay, see, that is a SCR, anode, cathode. See, there is a cathode and created. It is nearly equal to the Schottky diode, as its name indicates. That is mainly used for the control purpose. When small voltage are applied in the circuits, the symbol and Silicon Controlled Rectifier is shown in the here. Okay, see, that is anode and cathode in your gate terminal axis. It triggering that is indications. So it's a control device. Okay, you can using for voltage control or current control. That's using for the Silicon Controlled Rectifier. Rectifier means it's a anode to cathode. So alternative current to convert DC current. Okay, that's a DC direct current, it's a pulsating DC. That time you want to control how much voltage you want to, how much output frequency that will control. And one more thing is a beauty is three type terminals, anode, cathode and gate. Okay, this is a very important silicon diode. It will go for the voltage, it will come for this like this type of VN characteristics. It will come for like this. Here or is zigzag S methods, it will come for the voltage. Okay, that is a silicon rectifier. It's a silicon rectifier circuits. If we know means marker. Yes, marker is here. See this type of characteristics come like this. That is Schottky side. Okay, the voltage and current. Okay. Okay, students, that is a silicon rectifier. Okay, silicon rectifier. Okay, SCR, Silicon Controlled Rectifier. Okay. Next, vacuum diode. Okay, this two electrode diode. See, this one's vacuum diode is a very so act as a switch. See, that is a vacuum diode consists of two electrode which will act as a anode and cathode. Cathode is made up of, that is, tungstens, which emits the electrons in the direction of anode. Always electron flow, it will be cathode to anode only. It acts as a switch. See, that is a vacuum diode. Vacuum diode purpose here is in between gap is the vacuum. It's not continuously connected. And one more thing, see here anode and cathode in between gap vacuum, and you are using for the heater. Okay, in this one, if a current flow means what will happen, that is, if electrons in this tungsten are flowing, cathode is made up of tungsten which emits the electrons. This due to heater, the cathode is heating. Okay, after the cathode hit the heater, the cathode produces for electrons. In this electron beam transfer to anode. In this way, in this method, is electron flowing. So it acts as a switch. If you connected, it will this act as a switch. It's a vacuum diode. It's an important and special type of diode. Okay, it will produce anode to cathode. In this method also, working for the X-ray also. Okay, it's a vacuum tube is there. You are giving for high voltage, then it will be produced for the wave. Okay, that way using fluorescent, then X-ray cathode. That time in the X-ray wave transfer human body. That human body, it will, the muscles will be overcome, but the bone structure they did not absorb, they did not overcome. So in your fluorescent, in the frame for image in your bone structure. Okay, that's why we are taking for the X-ray machine. Okay, this is special type of vacuum diode. Okay, then next diode is a very important pin diode. PIN, pin diode. PN junctions and pin totally different. See here, there is one more small indications is there. The small indications, a pin diode. See, the input version of normal PN junction diodes gives for the pin diode. So normal PN junction, you can add here some material, that means intrinsic material. Intrinsic material means you can for the hole. Okay, the PN diode doping is not necessary. The intrinsic material means the material which has no charge carrier is inserted between the B and N region, which increasing area of the depletion layer. So we are using for the P and N type. In this P and N type, automatically increasing the area, depletion radio. There is a pin diode. So normal PN junctions we are adding for the impurity, that is impurities, adding impurity that is increasing for the depletion. Depletion means PN junction time you can give for the forward directions, it will automatically flowing, reverse directions are increasing. So in this way it acts as a PN junction. This is a symbol, pin diode. Okay. Next, there is a gun diode. Gun diode fabricated with the N-type semiconductor material. The depletion regions of two N-type material. Okay, this is a very thin two N-type material. So two N-type materials means, see here, there is a one forward direction, another one for the reverse direction. That is a symbol. This one for anode, this one for the cathode. That is called for the gun type. Okay. So the depletion region of two N-type material is very thin. When voltage increase in the circuit, the current also increase. After creation level of voltage and current will exponentially decrease. Thus this emit the negative differential resistance. Okay. So first diode is a forward, next one connected for same opposite. See, that's a symbol. In this way, increasing means both are increasing. Depletion there, the voltage increases, current also increasing. After one certain time, it will come for, it will flow. That's a negative resistance totally. So both are current and voltage both are increasing. That time it will flow for, that is a just like gun. How you are firing, same way it will come for the voltage and current both are increasing. Okay, that's a beauty of gun diode. Next, there is a vector diode. See, in this vector diode, I am already studied about here. There is a symbol, anode and cathode symbol. It is a presence of constant voltage. Okay, in the reverse bias states, the constant voltage. There is a capacity of changing the capacitance range with the circuits is presence of constant voltage flow. Okay, so changing the capacitance, it will come for the constant. Okay, already studied the circuit special type vector. Now, what's the applications? That is, you study the vector diode applications. Okay, that's important. First, voltage controlled capacitor. Okay, you are using for voltage and current. That is voltage control. Okay, you are using for PJT and FET. Okay, PJT is voltage control device. FET is current control device. Okay, voltage control capacitors, charge and discharge. Same way using for voltage control accelerators. Okay, it's free running oscillators we are using for the voltage control accelerators. Next, parametric amplifiers. Amplifier using for the 5 volt, 10 voltage you want to amplifying. Okay, so 5 voltage you can using for the 25, 50 voltage depending upon the component manufacturers. Okay, then frequency multiplier. Okay, it's an important factor. Frequency multiplier, I am already told that M1, M2, there is a F1, F2, F3, F4, 4 type of frequency. You multiplex, using that you can transmit, then demultiplex. So multiplex both frequency and come for one channel. There is a frequency multiplex. Then FM transistor and phase lock loops in radio, TV sets and cellular telephone. Okay, so Werther diode is very important charge and discharging component. Phase lock loop, PLL. FM transmitters using for the antenna receiving the signals. After the receiving signals, using local oscillator, the separate carrier frequency and message frequency. After the carrier frequency, message frequency, it will come for the tuned AFO, audio frequency signal. In before that, it will come for the carrier signal, message signal, it will come for the looking phase lock. There is a 90-degree phase shift, it will come for the lock that time. So you overcome this phase lock loop and then using for FM transmitter in Werther diodes. And the television set also using for the Werther diode, and cellular telephone you can use cellular telephone. It's a charge and discharging. Okay, so just like your battery, you want to charge and discharge, using same thing using for the Werther diode. That's indicating charge. It means light indicating green. If you want to low charge, it will come for red. There is no charge, it will come for ideal. There is not even your LED also glowing. Okay, in the cellular concept, this is using for the Werther diode. Very famous and important Werther diode special application. PLL, phase lock loop, and television sets and cellular telephone phones. Okay. Next, laser diode. Laser is a very best example. You must know about the laser diodes. Okay. Similarly to LED, light emitting diode, what you are doing? In the forward direct process, processing. You are giving for the forward direction. That time it will light glowing. That is in your voltage convert to light energy. Okay. So similarly to LED, light emitting diode, in which active region is formed by the PN junctions. Electrically, laser diode is PIN diode, in which the active region is intrinsic region. Okay, so I transfer for intrinsic regions added. Used in the fiber optic communications, barcode readers, laser pointers, CD, compact disc, DVD, Blu-ray, reading and recording, laser printing. See, it is a laser diode. They were giving for anode and the cathode. Input you are giving for anode, then cathode is opposite side, and that is anode and cathode. So diode, in this diode you are putting for to see there is a one more diode line. If you are doing forward directions, it will come for in your laser giving output. Okay, that is come for in your lasers. Now we do a lot of operation you are doing for the lasers. You want to cutting edge and using fiber optic communication, using for labor. Fiber optic you are using for laser diode to transfer laser. And barcode readers, you can use scanning barcode. Okay, in your nowadays a number of stores, mall are using for barcode to use materials to find out the rate, all those things using, and you are using for application, a number of applications. Okay, then laser pointer, you want to explain the PPT or you want to find out the gunshot. Okay, that's using for laser pointer to find out exact time. And DVD LCD, you know, that's compact disc to want to write and read using for laser. Okay, then reading writing you are using for the laser. Then laser printing, you know, laser printing you are using for the donor powder is there. In this donor you can put the creating for the voltage automatically frame for the light letters in this paper. Okay, this is laser printing. These are the laser diodes. Next slide you go for the types. It's a very important lasers. There is a different laser diode types. First one for double heterostructure laser, free electrons. So free electrons and holes available simultaneously in the region. Next is a quantum well lasers. Okay, double heterostructure. Double heterostructure is free electron holes available simultaneously in the region. Double. Okay, quantum laser having more than one quantum well are called multi-quantum well lasers. In this lasers is the multi-quantum well to create. Next one, quantum cascade laser. There are heterojunction laser which enable laser action at relatively long wavelength. Okay, long wavelength you can transfer. That's a quantum cascade laser. Okay, n number of quantum connected in the cascade format. Then separate confident heterostructures lasers to component then thin layer problems. In quantum lasers will go for the separate confident heterostructure lasers. Okay, this is a separate. Next, this is a distributed bar. This is a reflector lasers. It can be edge emitting lasers and vessels. Okay, this distributed fertilizer can be edge limiting your lasers. You are using, you want to cut in your unwanted tissue in your human body, you want to do operations, you can using for this. And separate containment heterogeneration laser, there is a high thin layer problem in quantum lasers. We go for separate containment heterogeneous lasers. Okay, these are different type of laser diodes we are using for in your application. It's important laser diodes we are using for the cutting this one and transferring optic is a laser importance. Okay, then avalanche diode. Okay, let's see here, this is a diode, anode and the cathode. Okay, see that's a one bend is there. Here now not bend. So come for two bend, immediately come for tunnel diode. Okay, so you will study the symbol carefully. So electronic device is a, you must know this, all those things. Okay, this is a passive elements work under the principle of avalanche breakdown. It works in reverse bias condition. It results large current due to the ionization produced p-n junction during reverse bias conditions. These diodes are especially designed to undergo breakdown at specific reverse voltage to prevent the damage. The symbol of avalanche, this is an important avalanche diode. Avalanche diode, if you see, if you go for the p-n junction, the p-n junction is not working for the forward direction. Only it's not working for the reverse direction. Sorry, it only connecting for the forward directions. If you go for the reverse directions, what will happen? In reverse directions, in your depletion layer width is increasing. At one point of view, finally we create more using electrons and positive negative resistance. More temperature is increasing. At the time, finally we come for the burst. So that time you that means damage your system, damage your equipment. You want to reduce, you want to save your equipment, means you can using for the avalanche diode. In this avalanche diodes, what you will doing? That is producing for the reverse bias conditions. In this reverse bias conditions, you want to stop, you want to reverse bias, the prevent, that means within the limit above it will producing, means automatically it will discharge to current in the ground. So in your equipment safe, after the forward bias, it will continue in this. This is called for the avalanche diode. It's a avalanche breakdown. Is the concept is that avalanche breakdown. Okay, avalanche breakdown means after that reverse bias conditions, there is after limited voltage crossing, means automatically the system breakdown. Particular voltage will be, particular diode will be damaged or stopped. This is a breakdown. It will overcome and using for the avalanche diode. Okay, these are important. This even this prevent specific revision voltage to prevent the damage. Okay. Students, thank you students. In this class, I want to conclude. What is the concludes means? First, you are studying about the inverting, non-inverting amplifier. First of all, what do you mean by electron device? And then you studied about the inverting and non-inverting amplifier. After that, diodes, different type of special diodes. Okay, p-n junction diode, it is a normal diode. Okay, special diode means starting from tunnel diode, okay, gun diode, p-n junction diode, Schottky diode, avalanche diode, barcode diode. These are the different types of diode. This is construction operations and as well as SCR, Silicon Controlled Rectifier. It's also studied. Okay, so this a different type of diode studied in this class. Okay, so thank you students. Remaining continue in the next class. Okay, so you must remember this diodes. Okay, it's a lot of applications. This diode is there. So each and every diode is studied. Laser diode is important applications. Okay, these are studied in this class. Okay, thank you students. Remaining continue in the next class. Thank you students.
Thank you, sir.
Okay, thanks sir.